Hello everyone. I'm back again with the new playlist on binary search. Now, you all would be aware of what is binary search, when it is used, and all those stuffs. Okay. I didn't want to go in details of those stuffs like when to use, how to use, what is this. Okay, a very simple binary search, from where it came, because linear search is like this, binary search is like this. No, I will take this first video as the simple video. So if you have a very few idea, I mean, you can watch this and get a better hands on with the binary search. What is it? But from the next video, I want to cover in a different way binary search. I want to change the picture of it. So people do think binary search is just related to finding mid and then doing this and then doing that. I mean, it's not just related to that. There are so many different templates. People do get confused while writing binary search code with simple mistake of L and R choosing, or if you are not properly aware of when to use what, I mean, where when to go by L to mid minus one side and mid to R, or L to mid minus one mid plus one to R, when to take that consideration. Key, you have to go until mid, or you have to go until mid minus 1, or you have to go until mid plus 1, or while L less than equal to R, or while L less than R. Sometimes you will return L, sometimes you will return R as the answer, sometimes you will keep answer. So there are so many confusions which I felt when I started learning binary search. So all the videos, I mean, I have seen is like they are not explaining when to use what, when to return L, when to return R, why this method only. It's for every question they will go, okay, this is where we will use binary search, uh, and we will do this kind of stuffs. So I just want to make it teach you in a different way than what you have learned about binary search. Okay, so first, for today's video, it will be a simple video on binary search. Mostly used, my binary search will be mostly used when you are given sorted array. Some basic stuffs to cover, just sorted array. And if we could, or if not sorted, then if we could find some conditions, if you can find some conditions to make it sorted. Okay. um and mostly linear search will take the time complexity of O of n, and binary search will take it for O of n log n. I sorry, O of log n. Why log n, you mostly know, because in binary search we will it was like divide and conquer like algorithm. Okay, you start with mid. If you are satisfying your condition at mid, then you will decide whether to go on the left side of mid or right side of mid. So one side you can ignore. So it's kind of that kind of structure of binary search. Fine. So normal algorithm, binary search is mainly for searching some element. Okay, you are given a target element and you need to find it from one sorted array. That how you, or whether this number is present or not present, return true or false, or if present, at which index it is present. Okay, so let me just write the normal code of it which you have seen until now. So until now you will be seeing L is equal to 0 will be done, R is n minus 1, and what you will do, you will have while L less than equal to R. This is the common approach they will do, but sometimes they do while L less than R. So when to use what, or to avoid this confusion, I have a new template. Okay, and then what people does is, they make a mid out of it. So for mid finding, this is the basic formula: L plus R minus L divided by 2. You will get to the mid value of L and R. L and R is a boundary, mid is the middle element. Okay, if you will check if your array of mid is equal to target, means what you have found, what you want to find, you will return. Else if you will see, if array of mid is lesser than target, so that is your target is bigger, so of course you need to go on the right side because the array is sorted. Correct. So you'll go on the right side. So for right side you will change your L to mid plus 1 for sure. Otherwise you will change your R to mid minus 1, and you will, if nothing will be returned until here, then you will return minus 1, saying that okay, we didn't find any element equal to target. So this is the normal code of binary search which you have learned until now. And this is very common, nothing to explain over here. Okay, binary search simply means that some pattern you will find in sorted order, where if you will find the answer in on the left side either, or on the on the right side of the array from the mid. Clear? Okay. So this this is basically for the approaches where let's say you are given a fixed target and there are only unique number of elements over here. Okay, there are no repeating elements over here, then this will mostly work. But there comes a some confusions, so I have a new template. Okay, so let's learn this new template a little bit, and I'll be covering in depth those new templates, the variations of that new template also, when I'll cover binary search on answer. That will be mostly my fourth or fifth video of this playlist. So I would strongly suggest you to follow this fully, as it will be connected end to end from the first video to the last video. Okay, so the modified algorithm says what you have to do. You will not do this while L less than equal to R. We will not do L less than equal to R. Then what we will do? We will do, we will do until R minus L greater than 1. Until R minus L greater than 1. So if L is 3, R should be at least 4. Okay, 4 or 5 or 6 or anything. I mean, R could not be 3. Okay, here L less than or equal to R is possible. No, L R minus L greater than 1, or you can say L less than R also. L less than R condition is also true. But this will go until R minus L greater than 1, means until R minus L is greater than 1, we will run this loop. Okay, or until L less than R. So there will only always be one gap between L and R. So if L is 3, R will be 4. Or should be 4, at least 4. Okay, fine. So for this type of case, which type of case? Where we need to find any target element in the sorted array. So this is the kind of our case. First case where we can apply binary search. First case of binary search. Please make a note of it. Something where we need to find any target element in sorted array. In sorted array. Okay. Then what we will do? Of course, we will have L is equal to 0. We need to search in array. So we'll have a 0th index and n minus 1th index. Our answer will be in between only. Okay, we need to return the index where we have find those target element. Then while R minus L greater than 1. So what could be the change here? When you come out of this while loop, okay, you will be left with you will be left with L and R. There are two things which you are left with, which you might not have checked in the mid. There could be possible that mid you have checked, but there is some condition which you have left with checking with L and R. So when you come out of while loop, there will be two variables with you, L and R. Depending on the question, depending on the question, check condition for L and R and return it. Now what does this mean? Let's see. Simply we will do mid formula will be same. Okay. L plus R minus L divided by 2. So if, let me tell you with example, if my L is 1, R is 10. 1 plus 10 minus 1, 9. 9 by 2, 4. Okay. So 4 plus 1, 5. 5 is my middle element between 1 and 10. Correct? So L plus R minus L divided by 2 is your middle element. Now, if mid satisfies condition, okay, then you can return mid. If mid is less than target, okay, then what you will do, what we have done above, L is equal to mid plus 1. So our answer will be on the right side, else our answer will be on the left side. Here we have done L as mid plus 1, R as mid minus 1, but this couldn't be the case everywhere. Okay, this is very fixed. This is similar to this, but we didn't have to do this case also. Either we could do, if mid satisfies condition, we can make R as mid or L as mid, because we are sure that if this is satisfying condition, our answer could be either on the left side or on the right side. I mean, in this case, it's fixed that once it satisfies condition, once we got the element equal to target, this is the fixed answer. But in many of the scenarios, the condition wouldn't be like exact answer returning condition. Here, the condition is like mid is equal to target, so you return that. Sometimes, sometimes not. Many a times, it would be like it's not the exact same condition. Okay. Okay. I'll go in depth with this template in my fifth or sixth video where it will be actually needed. I won't need it much for this 3 4 videos. Cool. So at the end, we are left with two variables. So we will check if array of L is equal to target. We will return L. If array of R is equal to target, we will return R, of course. Otherwise, we will return nothing. So these two conditions we need to check after coming outside for L and for R. This way, your confusion wouldn't be there in whether we have to do L less than equal to R or L less than R, or we should go with L is equal to mid, R is equal to mid plus 1, R is equal to mid minus 1, or R is mid and L is mid plus 1. Sometimes that confusions will come a lot. You will see when we go with the harder level of questions out of this. Okay, so for today's question, let me just go with the simple question of finding peak element. Now, what do I mean by peak element? By peak element, I would mean you are given a nums array. Let's say this 1, 2, 3, 1, 1, 2, 3, 4, 3, 1. This is the condition you will be given. So it's like until one point you go increasing and then you decrease. Okay, first increasing and then decreasing. So it's like a mountain. It's like a mountain. It's like this, first increasing and then decreasing, and you need to find this is called the peak element. Okay, this is the peak element which you will be finding. So how to do this, how to get this peak element is the question. So here the peak element is the highest element, in short highest element. So peak element is 4 in this case. Peak element is 4 in this case. Okay, fine. So the question says that we need to find the peak element for this. So how we'll do that? Okay, now just think of it with the middle condition. Always when you go for the binary search, think it with the middle condition. Okay, let's say I find some middle as 3. Okay, I find some middle as 3. So with whom I compare 3 with to get to know whether 3 is my peak element or not. So I could compare 3 with the element on right side of it and on the left side of it. Okay, so if I'm comparing this way, so it is increasing 3 and 4, it is increasing. Our condition is first increasing and then decreasing. So this is in increasing order, 3 and then 4. So this is an increasing order. So if it is an increasing order, for sure 3 is your not your answer. So your answer could be something beyond 3 only. So if 3 is lesser than 4, so if mid is lesser than mid plus 1th element, for sure your answer will be on the left side only. Or you could compare one previous also. So let's say is 3 is greater than 2. 3 is greater than mid minus 1. So mid is greater than mid minus 1. Again, this is sorted condition only. Mid minus 1 is smaller than mid element. So this is increasing condition. So we have said first increasing. So 3 could be my possible answer at that point. Okay. 3 could be my possible answer at that point. I didn't know of what is behind of 3. I just know what is ahead of 3. So in that case, I could put my L as mid. That okay, in this case, my L would be mid. Otherwise, in opposite condition, my R would be mid minus 1. Opposite condition will be what? Okay, there are two cases. Let me just explain you over here. If you will compare mid with mid plus 1 element. So if array of mid is always lesser than mid plus 1. So if you have find such mid element which is lesser than mid plus 1th element. Okay, this means this is an increasing order. Okay, so your answer lies, your answer could be mid plus 1. It could be the greatest element because it is all of course greater than mid. Okay, so or something beyond mid plus 1. So your answer lies on right side of mid for sure. So in this case, what you will do, you will make your L as mid plus 1. Okay, else condition could be what? Else condition could be what? Array of mid is greater than or equal to array of mid plus 1. This will be your else condition. Okay, the opposite of if. This is less than mid plus 1. This could be greater than or equal to mid plus 1. So what is that condition? If something mid I choose and it is greater than equal to mid plus 1, this case 3 and 1. So 3 and 1 is like 3 is greater than or equal to 1. So this is decreasing condition. Then your answer could be mid. It could be mid, could be the greatest element of full array. Could be possible. So it could be mid or something on left of mid. Something on left of mid, but for sure not on the right of the mid, because it is of course decreasing from this point. Okay, so it could be mid or mid minus 1. So at from mid from 0 to mid minus 1, so your r could be at mid at this point. Okay, your r will be mid at this point because you need to find the maximum element. Okay, now I will give you a template when I will be at my later stage of video, that when to decide mid plus 1 and mid in r l and r. Okay, then I'll remind you with this question again, but to give you a start kick of this, I have shown this question over here. I mean, what's the logic of it? Why am I confusing you with this all things? That why not to use this type of algorithms and why to go with this? Okay, you have done. Or another case you could think of is you have compared this case, that you compare this with mid minus 1. So you found that mid is less than mid minus 1. That could be, that could also be possible, that mid less than mid minus 1. Like this is the case. Sorry, this is the case. No, not this. Mid is lesser than mid minus 1. Mid is lesser than mid minus 1. Okay, so if I say 4 and 3. So if 4 is my mid, 4 is lesser. Sorry, 4 is not lesser than 3, right? Uh, 1 is lesser than 3. If I take this two case, 3 and 1, and my mid is 1, let's say. Okay, or I could take this 3 and 4. Then this 3's mid is lesser than mid minus 1 element, which is 4. Okay, so I should for sure go on the mid minus 1 side. So there what I will do, I'll take my r as mid minus 1, because my answer could lie from 0 to mid minus 1 for sure, or l to mid minus 1. Else condition, L will of course be mid only. You don't need to think it. If one thing is minus 1 plus 1, another thing could be in opposite case. It could be mid only. If one thing is mid minus 1, mid plus 1 fixed, other could not go as mid plus 1 in this type of scenarios where we are doing like this. If we are doing it with L less than equal to R, it could be anything. It could be plus 1 minus 1, it could be plus 1 mid, it could be minus 1 mid, it could be mid minus 1 mid, and then only mid plus 1. It could be anything. Very little, very confusion. And in returning also, it could be return L, it could be return R, it could be return mid. A lot of confusions over there. You need to go in depth for every test case to make it properly runnable code. But here it's fixed. When you are done with, once you are done with one condition, other thing is fixed. Here why I have returned like mid plus 1 and mid minus 1, because mid satisfying condition is true for sure. From here we need to return, then we can go to mid plus 1 mid minus 1. There, I mean, there are no harms in it. That's why. But I'll go in this template at the later stage, not today. But this is just to give you a kickstart. Okay, so if I'll move to final approach of this code, while r minus l greater than 1. Okay, my mid is, let's say, l plus r minus l divided by 2. Now I will compare it with, let's say, mid plus 1. So this is my increasing condition. Okay, then for sure my answer will be on the right side. Else my answer could be mid or on the left side of mid. I have made you explain why could be mid or on the left side of the mid. Okay, so after coming out, you're left with two cases, L and R. So now what you need to return? Either array of L or array of R. Whatever is bigger. So just compare. If array of L is bigger than array of R, then you will return L index. Otherwise, you will return R index. There is nothing like minus 1. Okay, we didn't need to find target, we need to find the index of the peak element. Okay, or if they have asked for the peak element, then return array of L or array of R, depending on who is bigger. I hope you got my point. So your answer lies in between. Your answer would be either array of L or R only. Okay, your answer would be L or R only when you come out. It couldn't be anything in between. Once you are left with one L and R, it should be that only. So your L and R could be 3 4, or could be 4-3. Nothing beyond that. Nothing beyond that. Okay. I hope you got my point. If not, it will be betterly clear when I go with the templates of this in my later videos. But just to give you a quick start, next video will be on the lower bound and upper bound methods. Okay, it's not related with this, but this is just to give you a quick start on what I'll be covering in the binary search. Something new, something template based, which you might not have learned, and might also getting confused like I do when I am studying binary searches. It looks a simple topic, a easy topic, but when we write the code of it, there are so many errors which we couldn't debug at that point during our interviews when the interviewer is sitting. And it happened with me, I guess 1 or 2 times with the binary search only. So that's why I've become now more specific with the templates of binary search. I hope you like the video. Share it with your friends if you have learned a lot out of it, and stay tuned for the next videos that would be very 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 important for your binary search to make it strong. Stay tuned, stay safe, bye bye.